Let's solve today's question. So the question says, okay, wait a minute, I got disconnected. Okay, I'm back on. Where's the question? Just a minute, guys. I could re-record this, but it's fine, right? Okay, you have seen a lot of wrong answers, right? I'll tell you what the problem was. Okay, so the question says that for a collection of integers, MEX of that collection is the smallest non-negative integer that does not appear in S. So MEX is the smallest integer that does not appear in that sequence. He decides to destroy the universe, and he can perform the following operation. Select L and R. L and R are the positions. It starts from 1 to n, and he can replace all the integers in that A of L to A of R to W. What is W? W is the MEX of all those numbers. Okay, so he decides the range and he changes all the numbers in that range to the MEX of that range, and the universe is destroyed if all of the elements are 0. So ultimately what we need to do is we will be given an array and we need to find the minimum operations in which we can turn this into 0. Okay, let's go to the problem. So we'll be given an array, and in each operation we can set an L and R position and turn all the numbers in that region as the MEX of that region. Okay, so for example, if I set L equals to 2, R equals to 4, then I need to change all these integers A2, A3, A4 to the MEX, minimum excluded non-negative integer of this range. So let's say this is our question, right? So what is MEX? MEX is the minimum excluded non-negative integer. So it can start from 0, 1, 2. MEX can be 0, 1, 2, 3, 4. The minimum element from this which is not present in the sequence. So let's say I check this sequence. In this sequence 1 and 5, what is the minimum number from this which is not included? It is 0, right? So MEX of this is 0. Let's say I say 0, 1, 2, 5. For these 4 numbers, what is the MEX? MEX will be 2. For 0 and 1 are already present. The minimum excluded number in this range is 2. So that's MEX. Now what we need to do is, we'll be given an array and we need to transform it all of these into zeros, right? So what I was thinking was, we just need to find all the non-zero segments, as all these non-zero segments will have MEX as 0, and it will replace all these elements with 0. So the number of non-zero segments will be the answer, right? That was my approach in the beginning, but it's wrong. Means you can get it the wrong answer. Why? Because let's say in this case the answer according to me is 1, 2, 3, 4. As there are 4 non-zero segments, the answer should be 4, but that's not the case. The answer is 2. How will it be 2? I'll give you some examples and we can find the logic from there. Okay, let's say we are given an array of all zeros. Okay, in this case there is no need of operation, so directly 0. Let's say I give you an array with all non-negative integers. This is an array. In this case we can directly set the first element as L, last element as R, and the answer is, in only one such operation, all the elements will be replaced by 0. Let's say now there is combinations. Okay, there are cases. Let's say combinations of non-negative and negative, 0 and non-zero elements. So I'll place 0 anywhere and I'll place random numbers Okay, this is the case. Okay, in this case, what does MEX do? Okay, let's say L to R, if there is a 0 element present. Okay, this is position 0, sorry, position L, this is position R, and between this position there is a element 0. So MEX will be a positive number then, because MEX is from 0 to such number, the minimum excluded number in this range, right? In this range, the minimum excluded number it will be. And MEX is always positive if it is not 0. If MEX is not 0, then whatever may be the MEX, it is always positive. Okay, and when there is all positive numbers like 4, 2, 3, 1, there are all positive numbers, what will the MEX, what will be the MEX? The MEX will be 0. Got it? So that was it. We don't need to do n number of operations, we just need to turn, if there is a 0 present, we'll turn this into a positive number, and then when positive number is there, directly the second operation automatically gives 0. That means my wrong approach was, let's say, wrong approach. Okay, wrong approach was that I'll select this non-zero segment and turn it into 0. Like it will be 0. I selected this as L and this as R. So in this region the MEX is 0, so this will be replaced by 0. So it will be 0 0 0 0 4 2 0 7. This was operation 1. In operation 2 I'll select this non-zero segment and then turn it like 0 0 0 0 0 0 0 7. In operation 3 I'll select this non-zero segment and it will be 0 0 0 0 0 0 0. Done. In 3 operations I did this, but this is not the minimum way. The minimum way is that if there is a non-zero element present in between, right, somewhere. So let's say these were all one, right, all were non-zero element, like I said here, when there are all non-zero elements in only one operation, where L is the first element, R is the last position, all the elements are non-zero, so the MEX will be 0 and it will all be replaced with 0. In just one operation the array becomes a 0 array, right? Okay, so let's say in this case, as there is a 0 element in present in between, what we is it possible that we can turn this array into a similar array, because from here directly the one operation is required. So if we find a way to turn this array with has 0 as its element, sum of its element, to an array with no zeros, is there a way? Yes, we'll directly do the same thing, this as L, this as R, and we'll do the MEX, right? That means the minimum excluded number. So in this case what's the minimum excluded number? 0 is present, 1 is present, 2 is present, 3 is present, 4 is present. So 5 is the MEX of this. MEX of the whole array is 5. So all of these will turn into 5. That is how many elements? 3 6 7 8. 3 6 7 8. Okay, this will be the array. This array gets converted into this array in operation 1. And this operation 1 is the resultant array is nothing but this case, right, that all elements are non-zero. Here all elements are non-zero, and from here on only one operation is required to make them all 0. Then again operation 2 with L as this and R as this, and all of them will turn into 0. So whenever there are non-zero, whenever there is a non-zero array, right, there is no 0 present, then we require one operation. Whenever there is a 0 present somewhere, right, wherever there is 0 present, we need two operations, the one to convert it into all with non-zero, and the second to convert it finally into the required array which is all zeros. And if all are already 0, then there's no need to perform any operation. These were the cases. Okay, so again, if let's say it was 0 0 0 and 4 4 2 0 3, in this case, let's say it's not 0, it is 5 here, right? 5 here, right? So what would you say in this case? In this case, as this first, the prefix is a 0 0 0, we don't need to perform any operation on this. We need to perform only this segment. And this segment, what is this segment? In this segment there is no 0 element. So directly in one operation with L as this and R as this position, we can transform this into 0 0 0 0 0, and this was already 0. So whenever there is a prefixes of 0 or suffixes of 0, that doesn't change the thing, right? I mean that if there is a prefix or a suffix, finally we need, let me show you, finally we need the array to look like this, right? And whenever there is a prefix of zeros or a suffix of zeros, that is already satisfied. So we only need to perform the changes on the middle part. And if the what all cases are in the middle part, these are the cases, right? These are the cases which I explained, that either all are non-zero or either there is a 0 in between two in between. So we just need to find the first non-zero element and the last non-zero element, and then find in between. If there is 0 present in between this, like if there was 0 here, then I would require 2 operations due to this case, right, which I showed you. And if there was no 0, in the segment, then directly one operation is required. Okay, that's the solution. So all these wrong answers were my wrong approach, which was I was finding the number of non-zero segments like this. Here in this case it is matching my approach and the answer is same, but the when I tried dry run for the longer array elements, it was wrong. So I got to know what approach was working and which was not. So these were the wrong elements, and the correct solution, see, I have kept a 0 counter. So if an element is 0, I'll increase the counter, and another flag element to find in between. Then I find the first non-zero element, the position of the first non-zero element. So till we find a non-zero element, we go on increasing from the left. That is, we find the first non-zero element, and similarly we find the last non-zero element, and in between those two positions, the first and last non-zero element, if there is a 0 present, that means we need 2 operations to do this. So I've just set a flag here. So if it is true, that means there is a 0 present, then we require 2 operations. If there is no 0 in between, we require 1 operation. And if all are 0, that means the number of zeros, CZ, is equal to the number of array elements, N, then directly 0 operations are required. So this was the answer. I hope you got the logic. Okay, thank you.